You were probably very disappointed when you learned that the type of the error that you catch in a traditional try-catch block is unknown, which is the least helpful type of all, and that you had to write type guards to narrow down the type of the error. Wouldn't it be awesome if the errors that you catch are fully typed, in the sense that your error is a union of all possible errors, and that you can enforce the handling of all possible errors in the type system? This is actually possible in FPTS by using the either type. The either type represents the result of a computation that can fail. To explain the either type, let's see how it is actually a solution to a limitation that the option type has. We have seen how the option type can be used to handle computations that can fail or throw exceptions. However, the option type is a bit limiting. While in the success case we get some A, which is a container that contains a value of type A, in the error case we get none, and none does not contain any data. So we know that the computation failed, but we don't know the exact reason. To fix this, we need another way to represent failure that carries some data with it. So instead of none, we'll have left E, where E is the data associated with the failure, such as an error object. For naming consistency, we'll also replace some A with right A, but conceptually it's the same thing, just a wrapper around the value of type A. So the result is the either type that can be either left E or right A. Therefore, either EA is defined as a union of left E and right A. That is, whenever you have an either EA, you either have left E or right A. Conceptually, we can look at an either as a box that either has a value inside of it or an error. For example, if we have either error or string, then we have a box that might have a string inside of it or an error object. In the case in which it actually has a string, like hi, we can see it inside the either box. We can create this particular either by calling the either right constructor with hi. On the other hand, if that either has an error, then the either box has the error object inside. We can create this either by calling the either left constructor with the error object. Let's look at an example of using either, which will show you how you can actually get type-safe errors. First, we will import the entire FPTS either module as a namespace E, which is a common practice in FPTS. Now, let's say that we have an app where each user has an account, which has a balance and a flag indicating whether it is frozen. Then, the user can have a cart, which has a list of items and the total to pay. Finally, the user can proceed to the checkout. The checkout function takes the cart and the account and pipes the account into a pay function to which it passes the amount to pay, which is just cart.total. Pay is a function that takes the amount to pay and the account and returns either an error that can be account frozen or not enough balance, or in the case of a successful payment, the account with the updated balance. The account frozen error is just an object that has a type and a message. Similarly, the not enough balance error is just an object with a type and a message. Returning back to the pay function, we first check if the account is frozen, and if so, return a left with the account frozen error, whose message is cannot pay with a frozen account. Otherwise, we check if the account has less balance than the amount to pay, and if so, we return a left with the not enough balance error, whose message is cannot pay amount with a balance of account.balance. Otherwise, we know that the account is not frozen and has enough balance, so we return a right with the updated account, whose new balance is the current balance minus the amount to pay. And that's it for the implementation of pay. So if we have an account that has a balance of 70 and is not frozen, and we pipe that account into pay 50, we get back a right with the account having an updated balance of 20. On the other hand, if we have an account with a balance of 30 and we pipe it into pay 50, we get back a left with the not enough balance error. Finally, if we have a frozen account and we pipe it into pay 50, we get back a left with the account frozen error. Note how returning an either indicates that the operation might fail, since the pay function is not guaranteed to always succeed. So we're using the either type to avoid throwing an error. Indeed, one of the biggest advantages of returning an either instead of throwing an error is that the possibility of an error is directly encoded in the return type of the function. So if we look at the signature of pay, we clearly see that it can fail and with what errors. If we instead implement pay as a function that returns the updated account and throws an error when called with with an account that is frozen or doesn't have enough balance, there is no indication in the type system that this function might throw. Let's return back to checkout. So after we pipe the account into pay with card.total, we get back an either. But how can we check if that either is a left or a right and do some action accordingly? We can use either match, which does pattern matching on an either, allowing you to return a value for the left case and for the right case. Note that you might also encounter either fault, which is just an alias of either match. Going back to checkout, we can pattern match the either returned by pay, and in the left case, we get the error and can take an action that handles that error. Note that for now, I am just returning a string since we haven't seen yet how to do side effects with FPTS. Then, in the right case, we get the updated account and can take some action to handle the success. Now, when handling the error, we see that it is correctly typed as account frozen or not enough balance, which is much better than having unknown. Going a step forward, it would be nice if there was an easy way to handle the different kind of errors separately. We can do that by using the TS-ADT library, from which we import makeMatch and create the match error function as a result of calling makeMatch with the type property, which allows us to do pattern matching on errors by using the type as discriminator. Then, when we handle the either's left case, we can just call match error with an object that specifies how to handle each error separately. And of course, we get autocomplete for all possible error types. This is really powerful, as we are forced to handle every possible error, which also means that if in the future the errors returned by the pay function change, we will have to update the errors that we handle, since we would get a TypeScript error otherwise.